You mean I didn't leave them all at once? Wow. All right. I hope you shared your weekend activities while doing your warm-up. So at this point, can you turn to your partner, please, and tell them what you think homogeneous and heterogeneous means, and which you think is which of these pictures. Turn to them and tell them. Homogeneous. Is it homogeneous? I've heard it both.
What do you think?
All right. So, in terms of our warm-up here, Noemi, can you tell us what you put down for what homogeneous or homogeneous means?
Something's like the same.
There, keyword there. Okay, how many people put down some kind of definition that had the word same in it? A chunk of you. Good. All right, and then, Gabby, could you tell us what you put down for heterogeneous?
The mixture is different.
Good, keyword there, different. All right, class vote. Do we think Kool-Aid is homogeneous or heterogeneous? Okay, how about the lava lamps? Okay, interesting. So same versus different. All right, we're going to go into solutions today. We're going to classify a bunch of these different solutions that I have in the test tubes over there. But first, we've got some homework to write down. So can you find your planners? It looks like a lot. Don't worry, it's not so bad.
That's what they always do.
I promise I'm not lying. There are good things ahead.
Yeah, like a minimum day.
Yes, I found out we have a minimum day on Tuesday, and I just learned about that on Saturday. So you guys know you have a minimum day tomorrow. So that's a reminder. Write it in your planner, write it on your arm. You're not supposed to be here much after 12 on Tuesday. Okay, so Tuesday is minimum day. Starting at the top here. On your way in, you picked up the solutions to unit packet. What I'd like you to do is start that packet, do about 2 pages, so one, front and back of that packet. Rather than have you do a bunch of reading notes, what I'd rather you do is do the unit review packet in lieu of doing the reading notes. Right? So that's your homework for tonight is the solutions packet. I will post it online just in case it disappears between now and when you get home. Then our second bit here. So we have a minimum day tomorrow. Block day, we have the ice cream lab. So just in time for it to be super, super hot. So what I need you to do for an extra stamp is to bring ice cream lab supplies. One sec. So you need half and half, sugar, and some kind of flavoring. You can bring, all kinds of different flavorings. I'm going to supply for you ice, rock salt, baggies, and I suppose I will supply some spoons so we're not slurping up our ice cream. Because it's not really going to be in a cone, unfortunately. All right, questions. Jacob.
Well, you answered.
Great. David. Nope. Tonya.
What do you mean by flavoring?
That was
Okay. So, let's say you're all about that, chocolate sauce on your ice cream. Fine. If you really like to have M&Ms in your ice cream, that's great. If you're all about vanilla ice cream, then include, bringing a little bit of vanilla would be totally acceptable. School appropriate additions are always welcome here. Yes.
How much chocolate? Gallon, half gallon?
Let me show you my milk carton here. Of course, I keep it on the demo desk out in the open all day. This would probably be good because remember, you're not bringing it just for yourself. So one person in your group's going to bring half and half, one person will bring some sugar, one person will bring some flavoring. So this would probably be a good size half and half. You'll probably have a little bit extra, but I think that the little tiny cartons that you get at the store are way, way, way too small.
So how much sugar?
This is a quart. And then let me double check with the sugar. I want to make sure we don't end up short sugar. So let's see.
Wait, when do you have time?
You're going to do it on the block day, so for you guys on Thursday. You're going to need just a couple tablespoons of sugar each person. So if you would bring a Ziploc baggie, like a Ziploc sandwich baggie with sugar on it, making sure it's really sealed very well, that would probably be more than enough. Okay? All right. Yes. On the block day. Yeah, no day's not enough time. We're gonna have an ice cream party here on Thursday. While learning why ice cream is a relevant thing to do in chemistry class, because it is.
Now let's just eat it. Just watch it.
Right?
Let's just eat it and watch it.
Of course not. We're going to learn about colligative properties and how solutions in ice cream are related to colligative properties. All right, so in order to decide who's bringing what, you're going to do this in your lab groups, which are the people you've been working with, so in your groups of 4. So if you could turn to them and quickly coordinate who's going to bring what, and then if you're one of those people who might forget, take out your cell phone and program a reminder in so you can tell whoever's at home, or remind yourself to go to the store and get yourself some half and half sugar, vanilla, chocolate sauce, whatever. Right?
How about sugar?
Maybe Tonya to Jordan, you guys can be a group of 3. And you guys can be what? You will see him probably tomorrow, would be my guess. Or we see my regular sugar, not powdered or anything. Regular sugar.
That was the worst suggestion.
Powdered sugar ice cream.
Yeah, it should be regular sugar, not powdered sugar or sugar cubes. Not going to be so good. It should be regular granular sugar. Okay, put it in your phone, put it in your planner, write it on your hand. Don't forget, I won't have extras. Yeah. Okay, then you're fine.
Wait, how long is it?
Not too long. It's pretty short. Maybe 14. All right. Do we have our grocery getters coordinated in our groups? Okay. All right. In terms of the extras, like the whipped cream or the chocolate sauce or whatever, when you're actually making the ice cream, unfortunately, you can't really put too much in it. But then once the ice cream's made, you can add the stuff. Simply because if you add a whole bunch of like vanilla flavoring, etc., that kind of stuff tends to keep the ice cream from actually forming. And we'll talk about why that is the case on the block day. Okay. Yes.
How much ice cream do you usually get out of this?
Maybe about a baggie full,
So
like a scoop. Are you always getting a scoop of ice cream in chemistry class? Oh my goodness. No, per person. Yeah, no, you don't get to. You don't have to share your one scoop of ice cream.
So like a Cold Stone, would you like a light it or a lemon?
Is the like it the little guy?
Yeah.
They really cram the ice cream in there, so I'd say like it. Yeah. It's going to be soft serve consistency, but it is ice cream, if that makes sense. Dave, you got that programmed in there? All right, come on. Okay, and then one more reminder here. Tuesday, again, middle of day, so we have a really short period. We have a couple things to do, depending on how the flow of things happen. Maybe we have to watch some of the Chernobyl video at some point. Which we haven't done last week. Yeah. Reminder, so SAT 2 class in the afternoons starts today after school. For that reason, my study center after school on Wednesday is not going to be like study center after school because I'm teaching the SAT 2 class in this room. So you're welcome to show up and like do whatever we're doing, but it is going to be the SAT 2 class and not like study center. Okay, so if you're in the SAT 2 class, you should be here after school on Wednesday with the bottled water because it's supposed to be like 95. Yes.
Even if we're like not in the SAT, we shall do some camera.
Yeah, you can. Yeah, but we will be. Our focus will be on SAT 2 stuff. Does that make sense? Yeah, but that's not a problem. All right. Any questions on ice cream, minimum days, SAT 2 class, solution factor? Fantastic. Let's start some solution stuff then.
Wait,
Yes.
the packet, is it front and back?
That could be one.
Or what?
I mean 2. Yeah. So one page front and back could be 2. As long as you finish it by the time the little sheet says finish it, then you're good. All right. So solution stuff. If you can find the lab you picked up on your way in, it is lab number 54, classifying mixtures. Okay. So we're going to start out by classifying some mixtures and figuring out what these things are. mixtures. We're going to decide whether they're solutions, suspensions, colloids, all of the above. No, that's not possible. It's one of the other. All right. So we're going to start over here in solutions land. Just a little bit of background information here. You guys are pretty familiar at this point with a lot of different examples of solutions. You've used a ton of them in class this year. So solutions generally are clear. Here it is. Clear. They're usually they're always homogeneous. Okay, so same throughout. They're pretty clear. They're usually transparent, clear, transparent, and homogeneous. Whoops. Smart board. Okay. These particles are super small. So solutions have super tiny particles in them. And I'm gonna put this word up there on the board, and we're gonna be like, what does that mean? But don't worry, we'll get there. It has no Tyndall effect. Okay. So let the phrase Tyndall effect jostle your brain a little bit. We'll come back to the Tyndall effect in just a second. Okay? So those are solutions. Those are things that you use a lot of in chemistry class. We've used less. We've used fewer suspensions throughout this year. I gave you an example of a suspension. If you guys ever had protein powder in milk or in water, that could be considered a suspension. Okay, so solutions are things like all these figures that are multiple colors, look pretty. A suspension would be something like protein powder. Okay? So these things tend to be cloudy, kind of like protein powder if you ever had that. They're usually heterogeneous. So they're different throughout. Every single drop is not exactly identical to the drops before. And you can usually see two substances visible. So if you haven't mixed your protein powder that well, it's definitely going to be a suspension, right? You'll see some solid protein powder, and you'll see some of the liquid base, either milk or maybe water that you mixed your protein powder in. These have larger particles. And you'll see some examples of that in the mini lab that we're doing today. Are you okay?
Your switch.
What? Oh, on the sheet?
Yeah.
Sorry. Just scribble out the heading. Oh, yeah. Scribble out the heading, change the headings around. Sorry, guys. Just scribble it out, right? Do a little arrow, right? Solutions are in the middle. Whenever I say it, it's always solutions, suspensions, and colloids. And that's why I put it in this order. So sorry about that. All right. Okay. The first column, this is about solutions. It should look this way on your paper. Apparently, I mixed up my columns. Sorry. All right. Now I know to tell third grade. It'll help me count. The last bit here, there is sometimes a Tyndall effect.
What is that?
I'm glad you asked. I will tell you in one more slide. I lied, in 2 more slides. It's kind of a cool thing, and I'm pretty sure almost all of you have probably experienced it and just didn't know what it was, or know that it had a name. Okay, and the last little bit here is these things settle out. So if you let it sit long enough, you're going to get separation. Oh, the smart one. Okay. All right, and then I put a jar of mayonnaise in the corner there, and also a glass of milk. This one's harder to see. And I did that for a reason. Those things are actually colloids. Okay? So when you're having mayonnaise on your sandwich, you can think about the colloids that you're spreading onto your bread. Okay? So colloids are cloudy, like mayonnaise, I suppose. But they're uniform. So uniform meaning the same. So they are actually homogeneous. But they're not clear, unlike solutions. Solutions are clear. Okay? These have small particles. And these do have the Tyndall effect.